All right. So yesterday we were doing this fractionating tower and we went on with different fractions from top to bottom in the fractionating tower. Let me revise it for you. The ones present at the top are known as lighter fractions, while the ones that are present at the bottom are heavier fractions. Now, let me give you a quick understanding over here, which we did not do yesterday. That is the very first part of this fractionating tower. The top part of this fractionating tower actually gives us gases. The whole central portion gives us a lot of different types of liquids. On top, we have lighter, less dense, less viscous, fill liquids which have lower boiling points, such as gasoline, such as naphtha. At the bottom, starting from kerosene, diesel, fuel oil, and lubricating oils, actually till fuel oil, we have dense liquid or very thick liquids, viscous liquids, liquids who resist their own flow and also appear to be thick liquids. Okay? However, when we talk about lubricating oils, and specifically wax made out of lubricating oils, we rather call it a soft solid. वैक्स के बारे में कैंडल वैक्स के बारे में आप श्योर होंगे कैंडल वैक्सेस भी सारी इसी से बनाई जाती हैं आप अंडरस्टैंड करते होंगे व्हाई डू वी कॉल इट अ सॉफ्ट सॉलिड आपको पता होगा कैंडल वैक्स कितना सॉफ्ट बिहेव करती है और जैसे आप थोड़ा सा उसके टेम्परेचर इंक्रीज करें मैं ये नहीं कह रहा हूँ उसे बहुत हीट अप करें स्लाइट इवन अपनी हाथों के दरमियान में भी अगर आप उसे अपनी फिंगर्स या अपने पाम्स के दरमियान में भी रब करते हैं यू वुड सी you can actually mold it like a play-doh जिस तरह बच्चों के पास प्ले डो नहीं होती और उससे प्ले करते हैं ठीक है उसे डिफरेंट शेप्स देके that is actually possible with candle wax ठीक so we rather call it a soft solid however at the very bottom of this fractionating tower is bitumen which is actually a hard solid in its original natural shape but that hard solid upon heating which given over here as 340 degrees centigrade its boiling point ठीक है actually we do not take it as high as to its boiling point, but a temperature little less than its boiling point would be good enough to melt it into a liquid and rather an easily flowing liquid, which can then be used for the surfacing of roads. All right. So that is how we treat with it. Now take a look. You would, upon taking a keen observation, understand that this preheater, let me annotate it with the spotlight, this preheater actually moves into the fractionating tower at a specific point. And at that point, there are two fractions which are below than that point, that specific level where the crude oil enters the fractionating tower, which means that this preheater's temperature, which was around 350 to 400 degrees centigrade, the boiling point of lubricating oils and bitumen might be higher than that. Now, you would say that the preheater's temperature is quoted as 350 to 400 degrees centigrade in the book, while here, right here in the diagram, the temperature for bitumen is 340 degrees centigrade. Let me tell you that these quoted temperatures are actually the starting boiling points of the fraction. Let me tell you, I explained yesterday that a fraction is not a one single compound. It's just merely a name representing hundreds of compounds in it. So the starting boiling point would be 340. Not all the compounds in the bitumen would boil at 340. Hence, there would be many compounds out of those hundreds of compounds which would boil at a higher temperature than 340 or even the preheater's temperature 350 or even 400 degrees centigrade, which means that they are usually not affected or most of the compounds in the bitumen or fraction are not affected by the preheater's temperature. So they simply pass down to the bottom without getting boiled. And that's the point, something you need to properly understand. That the gases are lighter, they're going to rise up and they're going to leave the fractionating tower from the very top. But the solids, specifically the bitumen fraction, okay, is unaffected by this preheater and still remain in their solid forms, and hence they go out of the fractionating tower from the very bottom. I hope that's clear, that's understandable. But if you still have a question, please ask. All right. So if you don't have any questions, there are very two important study tips on the next page, page number 278, which we need to go with. Number one, take care of the names for different fractions in different parts of the world. Note that the syllabus uses petroleum as the name of crude oil drilled from the ground and not petrol. So I've clarified it yesterday, and I told you that there is a specific caption under the table that there are different terms which are used in the British parts or the UK parts of the world, and then there are American parts of the world where other names are used. For example, crude oil and petroleum are two different names. The British people around the world, or UK controlled areas around the world, or UK affected areas around the world, which is pretty much a greater part of the world, okay, is actually that using that same name, crude oil. However, the American affected areas are using the term petroleum. Okay? In the same way, the British areas use the word petrol like we do, okay? But the American areas use the term gasoline. And when it comes to kerosene, kerosene is actually a USA based word. However, paraffin, the old word, is used in the UK affected areas. All right. So uh, in this case, there are different terms. Make sure specifically the term petroleum and petrol are not confused by you. The next study tip would be make sure the order of fractions, you know the order of fractions as they're produced from the fractionating tower and a use for each of the fractions. We went through it yesterday. I told you that's very important. A lot of past papers has that question. It is usually considered an easier question. We need to list a fraction and its use. So usually 2 to 3 fractions are asked in a 2 to 3 mark question, which is usually considered as an easy question. All right. Now, our next topic would be catalytic cracking. Once again, the students who are more fascinated by cars or transportation vehicles are going to be interested in this topic far more than the others. Now, before I go with this term catalytic cracking, I'm going to go with the demands that we have for different types of fractions from the fractionating tower. Just a second, beta. सॉरी मुझे फिर फ्लू हो गया तो मुझे बीच बीच में छींकें आ रही होती हैं So coming back to the demand, I'm talking about the economic demand. The economic demand for all the fractions is not equal. Okay, I discussed it yesterday. The petrol is in the highest demand when it comes to different fractions from the fractionating tower. Petrol is something that we use most, and of course we're going to demand it most. Then comes kerosene, then there is diesel oil, and there is light lubricating or heavy lubricating oil. Both are types of actually lubricating oils. Then there is fuel oil, and bitumen is the one that is least demanded. However, this blue cylinder is actually the gas. This is the gaseous portion. Gas and petrol are of the highest demands. But there is a far more amount of gas that is present on the planet than there is petrol. So we keep the gas apart. Let me tell you, there are a few reservoirs which only give us gas but do not give us petrol. But there are all the reservoirs of petrol usually give out the gas as well. ठीक है ये एक जनरल परसेप्शन है ये हर जगह पे करेक्ट होना जरूरी नहीं है ये मोस्टली केसेस में करेक्ट होता है जब आप अर्थ से डिग करते हैं अपने रेजर्वोयर्स तो कुछ ऐसे रेजर्वोयर्स भी होते हैं जिनसे गैस निकलता है लेकिन किसी किस्म का लिक्विड या सॉलिड मटेरियल नहीं निकलता जो हमारे पास फ्लोटेड है वो यूजुअली छोटे रेजर्वोयर्स पे होता है जो बड़े रेजर्वोयर्स होते हैं उनके इसमें क्या होता है कि हमारे पास लिक्विड तो निकलता है लेकिन लिक्विड के साथ सॉलिड और गैस भी निकलती है सो यूजुअली ऐसा होता है कि ज्यादातर रेजर्वोयर्स के केस में गैस जरूर एमिट होती है कुछ ऐसे रेजर्वोयर्स भी होते हैं जिसमें सिर्फ गैस होती है गैस के अलावा कुछ नहीं निकलता है तो हम ये कहते हैं and though this is not 100% accurate but for most of the reservoirs in the world they do give out gas so gas चूंकि हमारे पास ज्यादा अमाउंट में होती है तो हम इसे सेपरेट कर लेते हैं सारी डिमांड से और इस डिमांड टेबल में अगर हम गो थ्रू करते हैं तो हाईएस्ट डिमांड गोज फॉर पेट्रोल जिसका मतलब है पेट्रोल की डिमांड कितनी है इतनी ज्यादा है कि हमें इसके लिए कीप अप करने के लिए कुछ ना कुछ करना पड़ेगा. Now let's come with a few facts. Let me tell you, if all of this combines to be 100%, अगर ये सारा का सारा कुछ 100% है, ठीक है, तो हमारे पास जो पेट्रोल होता है, ठीक है, वो इसमें से इक्वल होता है अराउंड 20%. लेकिन अगर हम पेट्रोल डिमांड की बात करें, ठीक है, इन डिफरेंट पार्ट्स ऑफ द वर्ल्ड दो इट्स डिफरेंट. याद रखिए, जिस कंट्री में कार्स की यूज ज्यादा होगा, उस कंट्री में पेट्रोल डिमांड भी ज्यादा होगी. और जिन कंट्रीज में कार्स या उनका यूजेज कम होगा, उन कंट्रीज में पेट्रोल डिमांड भी कम होगी. अब आपका ये क्वेश्चन होगा, कार का यूसेज कैसे कम हो सकता है? तो कार का यूसेज ऐसे एक्चुअली कम हो सकता है बेटा कि हमारे पास जो कंट्रीज थोड़े से इकोनॉमिकली डेवलप नहीं होते, वहां पर नंबर ऑफ कार्स लेस होती है. फिर नंबर ऑफ कार्स एक ऐसा फैक्टर है जो पॉपुलेशन से भी इफेक्ट होता है. ज्यादा पॉपुलेटेड कंट्रीज में ऑफ कोर्स ज्यादा कार्स होती हैं, और लेस पॉपुलेटेड कंट्रीज में लेस कार्स होती हैं. ठीक, एक जनरल फॉर्मूला बता रहा हूँ, though there are many exceptions to it based upon the richnesses of the world, or riches which different people have in different parts of the world. Of course, जहाँ पर millionaires, billionaires ज़्यादा exist करते हैं जिस country में, वहाँ पर cars और उनकी demand भी higher होती है. So petrol demand जो है, वो हमारे पास approximately that is 50 to 60%, ठीक है, which is quite high. ठीक, आप एक जगह से अर्थ से डिग करते हैं, अगर वो बहुत अच्छा रिजर्वोयर भी है, तो वो मैक्सिमम, बल्कि हम ये जो 20% का वर्ड है ना, उसके साथ अप टू यूज करना चाहिए, क्योंकि मैक्सिमम 20% देता है. और पेट्रोल डिमांड जो है वो 50 से 60% के दरमियान एवरेज लाई करती है फॉर एनी कंट्री ऑफ द वर्ल्ड, विच इज क्वाइट हाई. इसका मतलब है किसी भी रिजर्वोयर से इतना पेट्रोल नहीं निकलेगा जितना पेट्रोल इंसानों को चाहिए या वो कंज्यूम करते हैं, which means we will always be producing less petrol than it is demanded. और ये एक बड़ा प्रॉब्लम है. According to economics of the world, when the demand is higher but the production is lower, this comes as a problem. ठीक है. Of course, अगर आप देखें कि आप रहीमा खान सिटी की बात करते हैं, let me give you an easy example. रहीमा खान सिटी की बात करते हैं, अगर हम डिमांड और सप्लाई की बात करते हैं, एक सिंपल चीज पिज्जा के लिए, ठीक है, लेट्स सपोज डेली बेसिस पे रहीमा खान में अबाउट 1 मिलियन पिज्जाज ऑर्डर करते हैं. जस्ट सेइंग, इतने होते नहीं है, लेट्स से 1 मिलियन पिज्जाज ऑर्डर होते हैं, लेकिन सप्लाई इतने पिज्जाज की हो ही नहीं सकती. सिर्फ हार्डली आपके पास जो है ना, वो 5 लाख पिज्जाज प्रिपेयर हो सकते हैं. तो इसका मतलब है कि for the rest of the 5 lakh people who are going to order pizza would be turned down for their offer. ठीक है, so ये तो problem create हो जाएगा. Of course, it's going to come as a problem every day. What if you are one of those people on a specific day who is going to order pizza but is turned down that we are already ran short of our supplies? ठीक, इसी वजह से पेट्रोल की डिमांड्स को मीट करना जरूरी है. The simplest solution is to produce more, but this solution does not lie naturally. So we need to come up with some artificial resources. We need to come up with some methods that we can increase the supply in order to meet the demands. ये बात सबको समझ आती है? What this simple diagram says, मैंने इसे अच्छी खासी डिटेल में इस डायग्राम को एक्सप्लेन किया. If there is still a question, please ask. Alright. So the solution to this demand and supply problem, in which the supply goes as high as 20% and demand goes as high as 60%, okay, we need to come up with a process in which the demand and supply rates can be equalized, or the problem can be solved. Moving back a little, page number 278, bottom heading, cracking. Tracking is actually the solution which tries to meet up the supplies according to the demands for petrol. Now, the term over here is not just cracking, it's catalytic cracking. First of all, let me define cracking for you. This is defined on the right-hand side paragraph over here, but in fact, let's go with the lines. The demands for various fractions from the refinery does not necessarily match with the supply from the oil. The lighter fractions such as gasoline are far more greater in demand than their supply, The opposite is true for heavier fractions such as kerosene, paraffin, diesel. So what do? We come up with the process cracking, and cracking is actually defined as when larger molecules from heavier fractions are broken down into smaller molecules, which are actually more valuable molecules in terms of their demand. Okay? This process is known as cracking. Now, cracking has three types. I'd like to write the names over here, and I would like you all to also write that at the bottom page. Now, cracking is defined over there, but cracking types are actually three. Number one, thermal cracking. As the name suggests, or as the word thermal suggests, okay, what we do is that we crack the material with the help of heat. Okay? Number two is steam cracking. We crack the larger molecules and break them down into smaller molecules with the help of steam. The third and the last type would be catalytic cracking, and as the name suggests, we are going to go with the cracking process, but in this cracking process this time, as a third part, in the last part, we're going to use some catalysts in order to speed up the processing. Okay? Short form, it is known as cat cracking. ठीक है? मैं इसे मजाक के तौर पे कहता हूँ बिल्लियां तोड़ना. ठीक है? So as the word cracking suggests, हम larger molecules को break down करेंगे smaller molecules में, and as the whole term catalytic cracking suggests, we're going to use catalysts in order to speed up our cracking processes. ठीक है? बहुत simple सी बात है. Let me. Are you done writing? याद रखिएगा आपके कोर्स में सिर्फ कैटालिटिक क्रैकिंग है, बाकी दो नाम आपको सिर्फ इंफॉर्मेशन के लिए बताए जा रहे हैं. And that's about it. जी मैं इसे रेज कर दूं written portion को.
Yes, sir.
Okay, good. So moving on to the next page. So why are we coming up with cracking? Take a look. इस पेट्रोल डिमांड को मीट करना है और हमारे पास बहुत लेस डिमांडेड काफी सारी फ्रैक्शन है. Fuel oil is less demanded, bitumen is least demanded, light and heavy lube oils are less demanded. So what do? हम ये करते हैं कि हम इन ऑयल्स को लेते हैं, ट्रैकिंग के प्रोसेस के जरिए इनके बड़े बड़े मॉलिक्यूल्स को ब्रेक करके पेट्रोल वगैरह में कन्वर्ट करते हैं और अपनी पेट्रोल डिमांड को पूरा कर लेते हैं. सिंपल इनफ. अब ट्रैकिंग मेरा ख्याल है सबको समझ आती होगी. कैसे करते हैं देखते हैं. Cracking takes place in a huge reactor. In this reactor, particles of catalyst. Now, this catalyst is not a single catalyst. It's going to be a mixture of many catalysts. Hence, there are many names written over here. Made out of powdered minerals such as silica. You're supposed to write the formula that I'm also going to write over here. Okay? But silica, as we studied back in chapter number 3, that is SiO2. Next up is alumina. Alumina actually is Al2O3. Okay? And then there are zeolites. Zeolites are actually minerals of sodium, potassium, magnesium, and calcium. However, you should be familiar with the formula of silica and formula of alumina. All right? So this is not just a single catalyst. It's actually a mixture catalyst. A mixture catalyst is a catalyst in which we do not use a single compound, we use more than one compound. Here we're using many. Sometimes we use 3 compounds, sometimes we use 6, sometimes we use 5, sometimes it's a mixture of even more than 10 different compounds. Out of which silica and alumina are in the bigger percentage. Now, these are mixed with a hydrocarbon fraction and a temperature around 500 degrees centigrade. Now, the book assumes that you do understand that there is absence of air or oxygen over here so that you are not going to go for an explosion. Because around 500 degrees centigrade or even a very little temperature than 500 degrees centigrade, you can easily burn up the entire reservoir of any fuel by simply giving out oxygen and using a small amount of heat. Okay? So book assume करती है कि यहाँ पर आपको ये चीज पता होगी कि in the absence of air or oxygen होता है. Tracked vapors जो होते हैं, जो इस सारे cracking process से आते हैं, उनके अंदर smaller molecules होते हैं, लेकिन as I told you before, it consists of hundreds of compounds. So what we do, we separate them by distillation, and here they mean fractional distillation. शॉर्ट एंड हाइड्रोकार्बन मॉलिक्यूल प्रोड्यूस होते हैं इस रिएक्शन से। ये रिएक्शन देखेंगे आपको बहुत इजी लगेगा। Decane with the presence of heat up to 500 degrees centigrade, catalyst, a mixture of silica, alumina, and zeolites, is converted into octane and ethene. Take a look. Decane, as the name suggests, is C10H22, an alkane, which is converted into octane, as the name suggests, is also an alkane, CH8H18. But ethene, as the name suggests, it's not an alkane. It's an alkene by the formula of C2H4. अब वो कुछ जो हमने चैप्टर नंबर 10 में पढ़ा है, जो हम एज्यूम करते हैं कि आपको पता चलता होगा नॉमेनक्लेचर से इसके नेम्स, टाइप्स ऑफ फॉर्मूलाज से इनके फॉर्मूला, और जनरल फॉर्मूला से ये करेक्शन कि क्या आप इसका फॉर्मूला ठीक लिख रहे हैं या नहीं लिख रहे, ठीक है, ये सब कुछ पता चलता है. सो वी assume that you remember everything from chapter number 10 in order to understand the simple equation in chapter number 11. ठीक है, आपको पता होना चाहिए ऑक्ट 8 को रिप्रेजेंट करता है तो C8 होगा. आपको पता चलना चाहिए कि एन अल्केन को रिप्रेजेंट करता है और अल्केन का जनरल फॉर्मूला CnH2n+2 था, तो 8 into 2 16 plus 2 is equal to 18. That means number of hydrogen atoms would be 18. ये सिंपल सी चीज सबको समझ आती है. ये हमने काफी प्रैक्टिस की हुई है, ठीक है. आई होप सबको क्लियर होता होगा. सो आप देख सकते हैं कि इतना बड़ा सारा डिकेन मॉलिक्यूल है. हमने इसे ब्रेक डाउन किया विद द हेल्प ऑफ कैटलिस्ट एंड हीट, और हमने इसे ऑक्टेन में कन्वर्ट किया और इससे एथीन प्रोड्यूस हुआ. नाउ वन पॉसिबल क्वेश्चन ऑफ माय स्टूडेंट इज व्हाई ऑक्टेन. लेट मी टेल यू कि पेट्रोल जो होता है, जो आजकल हम इस्तेमाल कर रहे हैं, इट्स एक्चुअली एन आइसोमर ऑफ ऑक्टेन. ठीक है, द पेट्रोल दैट वी यूज is mostly consisting of C8 molecule chains. ठीक है, तो हम C8 में कन्वर्जन सबसे अच्छी कन्वर्जन समझते हैं. ना टेक अ लुक. एक अल्केन यानी एक पूरा सिंगली बॉन्डेड कंपाउंड हमने लिया है, उसे दो कंपाउंड्स में कन्वर्ट किया, जिसमें से एक लॉन्गर चेन सिंगली बॉन्डेड है, लेकिन जो शॉर्टर चेन है वो डबल बॉन्ड रखता है, which means an unsaturated compound was broken down into a mixture of saturated and a saturated compound is broken down into a mixture of saturated and unsaturated compound. I hope ये बात भी सबको clear होती होगी. Last paragraph for today. This is just one of the possible reactions when decane is cracked. There are many possibilities with this reaction. The molecules may not all break in the same place. The alkane fragment is not always ethene. It can be propene, it can be butene or butanene, may also be produced. So cracking reactions have two possibilities. Number one, an alkane with shorter chain than the original one, and a short chain alkene may be produced. This is the first type. This is the first possibility or outcome that we have previously discussed in the form of an example. The second possibility for which the example is not given over here is that we only get alkenes and hydrogen would not get an alkane out of this. This may also happen. But this is something, the second possibility or second outcome is something that we are going to discuss tomorrow, not today. But so far, if you have any questions, please ask.